And as you can see, it's manifestly symmetric under cyclic permutations of N1, N2, N3. And that's again a proof, if you wish, of the triality. Okay, I guess I should stop here. Thank you. About what?
The bracket, square bracket.
Oh, by square bracket I mean supersymmetrization.
Super.
Yeah. So in order to when you want to supersymmetrize this affine symmetry, you simply add real adjoint fermions to this, and that makes it n plus 1 supersymmetry.
So anyone, capital N1 and N2 eventually have to satisfy some pseudo-limit inequality.
Right. I should have, yeah, Kazuo made a good point. I should have stressed it earlier. Now, you could have asked me at that point that if I'm claiming that the theory is related to this theory by cyclic permutation of N1, N2, N3, there is a range in N1, N2, N3 space for which these theories don't make sense. Namely, the range that the triangle N1, N2, N1, N2, N3 do not satisfy the triangle inequality. In that case, you will get some frame with a negative rank, a formal negative rank. What does that mean? In fact, that is precisely the case that turns out to break supersymmetry dynamically. And the way you do it is you compute this elliptic genus and you see it's zero. You compute it in a different frame, of course, in a frame that makes sense, and it is zero.
So N1 and N2 control zeros and ones in the elliptic genus?
It's not that straightforward. No. It's not an analytic function.
So is there any simple, so how does this connect to all the four manifold we talked about yesterday? So all this series presumably come from some 2, 0 rough on 4 manifold. Right? So what does it actually tell us in the end?
Yeah, that's a good question, and ultimately I would like to make that identification.
I guess that's your program eventually.
That's the program.
Yeah.
But I don't quite know. I mean, actually, yeah. Let me say this. Let me make this comment. So in the previous talk, I briefly mentioned that it's actually cutting and going 4 manifolds that landed us onto this dualities. How did that happen? So if you remember, there was this airy space to which I glued a cylinder. I mean, not quite a cylinder, but some cylindrical looking thing with some homological cycles. So this is an airy space which you can thought of as resolved AP times singularity. And this whole thing is a resolved AP plus 1 type singularity. It turns out that you do have such a piece which can take you from this to this. And this has 1 2 cycle, only 1 2 cycle with self-intersection over minus T times T plus 1. Okay. And I said that corresponding to this is the affine symmetry SUP at level N. Okay. And associated with this SUP plus 1 at level N. So you can associate this piece, the coset SUP plus 1 at level N divided by SUP at level N. But there is another way of thinking about what the theory should be. So if you are used to this superconform indice in 4 dimensions, you could either use a representation basis or continuous basis of gaseties. And you can go from one to the other by simply conjugating Fourier transforming with respect to the characters, the Schur polynomials of the group. So this in some sense is the discrete representation. And if you want to go to the continuous representation, you need to multiply with the characters of UN at level T. And if you do that, this simply becomes theory of free fermions, NP free fermions. Okay. And this bluing can be thought of as a gauge, as gauging in 2 dimensions, 0, 2 theories. And then you can try to figure out whether there is such a thing. For example, can you start with NP free fermions, do some gauging operation, and get n times p plus 1 free fermions. And you can figure out that there is such a thing. And that already is a non-trivial statement about 0, 2 theory. And if you try to think about, try to generalize that, this is where you land, the trialities. But this is one very special case of triality which has a place here. But I don't know in general what all these things mean.
And you say you also mentioned about solving four manifold. This is within Rafa twist and eventually localized on the instant locus. So do I think about those results and 2D 0, 2, 0 or something like wall volume theory of the instant zone?
No.
It's different.
Yeah.
I see, okay.
I mean, in particular, instanton model spaces can be really, 5 or 7 dimensional. But as you saw, I mean, are you saying what volume, or you want to think of it as a target space into the instanton model space? If you think of it as target space, doesn't make sense because you need for 0, 2 symmetry, you need a Taylor base. But if you have something else in